Good day everyone, my name is Jason Teodoro, and on this video, me and my group mates will discuss the designing system integration solutions and enterprise integration patterns. In the previous lessons, you were able to understand what middleware is. It is any type of software that facilitates communication between two or more software systems. It can be simple communication connection between applications. It can also be sophisticated as information sharing and logic execution mechanisms. In this lesson, you will further understand how to design system integration solutions and the different integration patterns. This lesson's objectives are: define tight coupling and loosely coupled. Understand the process of exchanging piece of data through messages via channel. Understanding the things that makes up middleware. And lastly, develop integration solutions. A middleware is a technology that allows to move information between multiple systems that may reside within and outside an organization. Message-oriented middleware, or MOM, is a queuing software that uses a message as a mechanism to move information from point to point. MOM uses the notion of message to communicate between applications. MOM also resolves the problem of tight coupling between applications. To make it simple, MOM is a software or hardware infrastructure supporting sending and receiving messages between distributed systems. Tight coupling. A great example of tight coupling is a local method invocation. Invoking a local method inside an application is based on a lot of assumptions between the called and the calling routing. Both methods have to run in the same process and be written in the same language, or at least use a common intermediate language bytecode. The calling method has to pass the exact number of expected parameters, each using the correct type. The call is immediate. The called method starts processing immediately after the calling method makes the call. Meanwhile, the calling method will only resume processing when the called method completes, meaning the invocation is synchronous. The communication between the methods is immediate and instantaneous, so neither the caller nor the called method have to worry about security in form of eavesdropping third parties. All these assumptions makes it very easy to write well-structured applications that break functionality into individual methods to be called other methods. Example problem for tight coupled solution. Assume that the team is developing an online banking system that allows clients to deposit funds from another bank into their account. Only the person's name and the amount are required as inputs for the remote function to deposit money into their account. The front-end web application must be linked with the back-end financial system that handles fund transfers in order to fulfill this job. The TCP or IP protocol is the simplest technique to link the two computers. A TCP or IP stack can be found in an operating system or a programming library. TCP or IP is a widely used communication protocol that transmits data between the millions of computers that are linked in the internet and local networks. This simple integration method is quick and inexpensive. However, it is brittle since the two parties involved make the following assumptions about each other. A. Platform technology. Internal representations of numbers and objects. B. Location. Hard-coded machine addresses. C. Time. All components have to be available at the same time. D. Data format. The list of parameters and their types must match. When two people communicate, coupling is a measure of how many assumptions they make about each other. The participants must make a number of assumptions in order to follow this example. As a result, this solution is inextricably linked. Loosely coupled solution. Instead of developing a tightly connected solution, the team can use a message-oriented middleware architecture to create a loosely coupled solution. MOM mechanisms offer a variety of services including A. A common data format and transformers removes platform and data format dependencies, as the sender no longer has to depend on the receiver's internal data format. B. Queuing channels removes location and time dependencies as team no longer have to pay attention to computer's identity and location or whether the other computer is ready to accept requests or not. Removing these dependencies between the system makes the overall solution more tolerant to change, the key benefit to loose coupling. In conclusion, it is better to use loosely coupled solution because its goal is to reduce the dependency level, while the tight coupled solution needs the dependency to be high, therefore reducing the flexibility of the system.
The things that make up middleware. First, what is middleware? Middleware are things that sit between applications, meaning it is the bridge between the OS and application in a network to connect two systems via an integrated solution. What do we mean by integrated solution? When we say integrated solution, it is solution provided and established overcome if system changes or challenges that may arise. Application wants to exchange data via message. Message are a snippet of data that has an agreed upon meaning to both applications that are to be integrated. This piece of data can be very small, such as phone number of a single customer that has changed, or very large, such as the complete list of all customers and their associated address. When application wish to exchange a piece of data, they wrap it in a message. Number 1. Message intent. Command message invoking a function or method on the receiver. For example, in a system, we write a command for the computer or system to perform. This could be any type of message. An example of this is when I share an encrypted data to one of you, this will require or request an access. A request for access is a command. Document messages, enabling the sender to transmit one of its data structure. This is where the sender contains or transmit data structures to another. Example, for this is Gmail. We often use this platform to send or transfer file from one person to another. It contains any document we wish to share with. Event messages, notifying the receiver of a change in the sender. If there's any changes regarding the message of the sender, this message will take place to inform the receiver. Number 2. Returning response. A. Request reply. The request is usually a command message and the reply is a document message containing a result value or an exception. This is where the message states a request for a reply. This document contains the result values. This contains whether the receiver needs to reply to a specific message. The most commonly I see, this is a follow-up message where the client is asked for some reply and is compulsory to process some documents. B. Return address. The requester specifies what channel to use to transmit the reply. In this, the address to be used was identified to where the reply takes place. This is where the reply returned to. For example, use reply to an email, the reply will return to the same address. C. Correlation identified. Responder specify which request is reply corresponds to, which means it identifies on which a response is responded. 3. Huge amount of data. Message sequence. Breaking the data in more manageable channels and send them a sequence of message so that the receiver can reconstruct the original data structure. This tells that if a huge amount of data is to be sent, it is divided into small manageable pieces and sent in a sequence, and the receiver reconstructs it to the original data. 4. Show message. Message expiration. The sender can specify an expiration data. If the messaging system cannot deliver a message by its expiration, it should discuss the message. If a receiver gets a message after its expiration, it should discard the message. Channel. Data needs to be transported, usually across a network. Communication channels are needed to move information from one application to the other. This channel could be a series of TCP or IP connection, shared file, or a shared database. A channel is a logical address that both sender and receiver can agree on the same channel without being aware of each other's identity. The application selects a particular channel to send the data, knowing that the receiver will be one it's looking for the sort of data on that channel. In the picture below, it shows the process of sending message up to another. This will see application 1 prepare the message and go to a channel and received by the other app. Channel is the path for transmitting data. Example, computer 1 is sharing a data to computer 2. We use LAN or WAN in order for them to communicate or share and trace each other through a network.
A point-to-point channel ensures that the only one receiver consumes any given message. If the channel has multiple receivers, only one of them can successfully consume a particular message. Example, telecommunication, in which one telephone is connected with one other, and what is said by one caller can also be heard by the other. In a publish-subscribe channel, it has one input channel that's split into multiple output channels, one for each subscribers. When an event is published into a channel, the publish-subscribe channel delivers a copy of the message to each of the output channels. By using a separate data type channel for each type of data, all of the message has a given channel will contain the same type of data. The sender, knowing what type of the data is, will need to select the appropriate channel to send it on. An invalid message channel is used to store invalid message for developer to analyze. A message is put into an invalid message channel if it can be sent to the receiver successfully and cannot be processed by the receiver because of its contents. For example, a message missing a header such as authorization or cookie header, where basic authentication is used is a candidate for invalid message channel, whereas a message that has an invalid value for a field should not be put into an invalid message channel. In other words, the invalid message channels contains messages that are deemed invalid because of coding or configuration issue in the sender or the messaging system, as the message in the invalid message channel have coding or configuration issue. They cannot be retried. Dead letter channel is the only error handler that supports moving failed message to dedicated error queue, known as the dead letter queue. Unlike the default error handler, the dead letter channel will by default handle exception and move the failed message to the dead letter queue. A guaranteed delivery channel is point-to-point channel that guarantees that the message will be delivered to the recipient. It means that delivery will be performed even if any error occurs. A channel must have a variety of mechanisms and checks to guarantee delivery. For example, the message must be stored on disk in case the system crash. The adapter acts as a messaging client to the messaging system and invokes application function via an application supply interface. This way, any application can connect to the messaging system and be integrated with other application as long as it has a proper channel adapter. So basically, there is no practical way to connect two complete messaging system. So instead, we connect individual corresponding channels between the messaging system. The messaging bridge is a set of channel adapters where the non-messaging client is actually another messaging system and where each pair of adapter connects a pair of corresponding channels. So the bridge acts as a map from one set of channels to the other and also transform the message format of one system to other. The connected channels may be used to transmit message between traditional clients of the messaging system or strictly for message intended for other messaging system. Message bus is a combination of common data model, a common command set, and a messaging infrastructure to allow different systems to communicate through a shared set of interfaces. This analogous to communication bus in a computer system which serves as the focal point for communication between the CPU, main memory, and peripherals, just as in the hardware analogy. There are a number of pieces that come together to form the message bus.
Middleware needs to provide some mechanism to convert one application data format in the other's internal data format. An application can often be changed. For example, one data format may store the customer's name in two fields called first name and last name, while the other system may use a single field called customer's name.
Good day, sir. I'm Gerald Tolentino. I'm Group 6. Tackle for today is message transformation. Number 1. Envelope wrapper. Wrap message payload data into an envelope that is compliant with the requirements of the messaging infrastructure. Envelope wrapper is used when the message payload header plus body is wrapped inside the payload for sending the payload through network. Most messaging systems divide the message data into header and the body. The header contains fields are used by the messaging infrastructure to manage the flow of message. However, most endpoint systems that participate in the integration solution generally are not aware of these extra data elements. In some cases, systems may even consider these fields are erroneous because they do not match the message format used by the application. On the other hand, messaging components that route the message between the application may require the header fields are would inside a message invalid if it does not contain the proper header fields. Number 2. Content enricher. When the target system requires data fields that the originating system cannot supply, it has the ability to look up missing information or compute it from the available data. Content enricher. The content enricher adds the content of payload with the original message in the course of integration process. This converts the two separate message into a single enhanced payload. These features enable you to make external calls during an integration process to obtain additional data, if any. Number 3. Content filter. Removes unwanted data from a message. Content filter. Content filtering is a process that manages or screens access to specific emails or web page. The goal is to block content that contain harmful information. Content filtering programs are commonly used by organizations to control content access through their firewalls. They can also be used by home computer users. Content filter is important. Content filter prevents access to content that could pose a risk to internet users. It blocks access to content deemed illegal, inappropriate, or objectionable.
Number 4. Claim check. Removes data from a message but store it for later retrieval.
Claim check store message data in present tense store and past claim check to subsequent components.
Number 5. Normalizer. Translate a message arriving in many different formats into a common format.
Normalizer use normalizer to route each message type through a custom message translator so that the resulting message match a common format. The normalizer use message router to route the incoming message to the correct message translator. This requires the message router to detect the type of incoming message. Many messaging systems equip each message with the type specifier field in the message header to make this type of task simple.
Number 6. Canonical data model. Design an independent data model from any specific application. Require each application to produce and consume message in this common format.
Canonical data model. Canonical data model provides an additional level of indirection between application individual data formats. If a new application is added to the integration solution, only transformation between the canonical data model has to create independent from the number of applications that already participate.
Routing. The middleware needs to take care of sending message to multiple systems. As the number of systems increase, it becomes very tedious and requires the sending system to have knowledge about all other systems. For example, if the customer's address changes in the customer care system, that systems can be responsible for sending data to all other systems that store copies of the customer address. It is expected that each application specific to target system for the data it's sending over the channel.
System management. First, let's talk about what is system management. System management refers to the centralized management of an organization. It is an umbrella term and includes a number of tasks needed to manage and monitor IT systems. System management is strongly influenced by how networks are managed in telecommunications. Integration solutions can quickly become complex because they deal with multiple applications, data formats, channels, routing, and transformation. All these elements may be spread across multiple operating platforms and geographic locations. In order to have any idea what is going on inside the systems, it is essential that system management function be recognized. This subsystem monitors the flow of data, makes sure that all applications and components are available, and reports error conditions to a central location. First is control desk. Provides a single point of control to manage and monitor a distributed solution. Number 2, detour. Route message through additional steps such as validation or logging. Number 3, wiretap. Inspect the contents of a message without affecting the primary message flow. Number 4, message history. Read aid to know where a specific message has been. Number 5, message stored. Can provide a complete amount of every message that traveled through the system. Number 6, smart proxy. Track message sent to a request reply services. Number 7, test message. Actively verifying that the running messaging system is functioning properly. Number 8, channel closure. Remove all remaining messages from a channel so that the components are under test do not receive leftover messages. Endpoint. Most packages and legacy applications and many custom applications are not prepared to participate in an integration solution as they were designed to perform specific functionality with specific input and output. Message endpoint is needed to connect the system explicitly to the integration solution. The endpoint can be a special piece of code or an adapter provided by an integration software vendor. First is messaging gateway, a class that traps messaging specific method, calls and exposes domain specific methods to the application. Number 2 is messaging map, creates a mapping logic between the messaging infrastructure and the domain objects. Number 3, transactional client, make the client session with the messaging system transactional so that the client can specify transaction boundaries. Number 4, calling consumer, explicitly makes a call when it wants to receive a message. Number 5, event-driven consumer automatically handles messages as they are delivered on the channel. Number 6, completing consumers, create multiple consumers on a single channel so that multiple messages can be perceived concurrent. Number 7, message dispatcher, consumer messages from a channel and distribute them to the performers. Number 8, selective consumer, filters messages delivered to a channel so that it only receives the ones that match its criteria. Number 9, durable subscriber, to make the messaging system to save messages published while the subscriber is disconnected. Number 10, independent receiver, can safely receive the same message multiple times. Number 11, service activator, connects the messages on the channel to the service being accessed.